All right, hopefully you've taken some time in order to do the multiplication problems on page 5 and 6 of the chapter 12.2 notes. And I'm going to go over those problems now. This video may end up being longer than 5 minutes because I'm going to do all 3 of these examples. All right, so we are first of all looking at x squared. X squared doesn't factor at all, so we're just going to write it down. X squared plus 2x plus 1 is a perfect square trinomial. This one is a perfect square, this is a perfect square, and the root of this and the root of this times 2 equals that. So we are going to rewrite this one as the root and the root, quantity squared. Whatever the middle sign is the middle sign. And then multiplied by x plus 1 in the numerator, doesn't do anything with that. And then x squared minus x, that has a GCF in it. And so we're going to take out the GCF, which is an x, and that's going to leave us with an x minus 1. And now we're going to go ahead and cancel. So we are looking at this, and we have one of those x's, which will cancel with one of these. And then one of those x plus 1s will cancel with that x plus 1, and then we can rewrite it. So we're going to have a numerator that looks like 1 times x, which is x, and a denominator that looks like x plus 1 times x minus 1. Now again, remembering if you are in an intermediate algebra text, a lot of times that's where they'll leave it. That's probably where our text, Lehman's text, would leave it. However, remember, if you're in a basic algebra text, they very well may rewrite this as x over an x plus 1 times x minus 1. When conjugates multiply, you get the square of the first minus the square of the second. And so that's the way that it may look in a beginning algebra text. Just pay attention to how your text does it if you're watching this video and aren't using the Lehman text. All right, in our second example here, we have a whole number essentially. And I would put that over 1, right, so that we can see that. So our first job is to factor that. So x squared minus 25, that's a binomial, it's a difference, that's a square, that's a square. So we need the roots of each of these, and we're going to form the conjugates. The root of the first one and the root of the second one, and the root of the first one and the root of the second one, and one gets a plus between it, and the other one gets a minus between it. And now we have times, and nothing happens with the x minus 1, so I'll just copy that down with or without parentheses. It's totally up to you. Then this is a leading coefficient that is not 1, so I'm going to multiply 5 times 2 and get 10, and then I need the factors of 10. That will give me a sum of 11, and so 10 and 1 will do that. So what I'm going to do is using that as a jumping off place for factoring this in the traditional method. So I have factors of 2, which are only 2 and 1, so I'm going to start there. And then I'm going to put the factors of 5, which are only 5 and 1, so I can get a product of 10 and a product of 1. So I put a 5 out here, so my outside product is 10, and a 1 in here, so my inside product is 1. And I need them to both be the same sign because it's a sum, and I need them to both be negatives. And now that I have that factored, now I can do my canceling. So canceling, I have one of those going with one of those, and that's it. There are no others. So I'll rewrite this as an x plus 5 in the numerator times an x minus 1 in the numerator, and that's all over a 2x minus 1 in the denominator. And that is, again, how most intermediate algebra texts would leave it. However, if you're using a basic algebra text, you very well may see this rewritten as x squared plus 4x minus 5 all over 2x minus 1, where they have literally multiplied out the numerator so that it looks like a polynomial over a polynomial. Moving on to part D, again, pardon me, we're going to put this over a 1, and from there, then we're going to go ahead and factor. So we're going to put this in as a negative out of here because this is my leading coefficient, or should be my leading coefficient. So I'm going to factor out a negative from this before I ever start, giving me a positive 2x squared, a minus x, and a minus 3. And so then I will have an x over that negative times, and then a 2x, and an x because that's the only way that 2 is going to factor. And now I need to put the factors of 3 in so that I'm going to get a difference of 1. So I'm going to put the 3 here and the 1 here. And I need a negative 1, so I'm going to have a negative 3 and a positive 1. So you see my outside is a product of 2 and my inside is a product of negative 3. And then times, and then I already have my numerator factored over here, x plus 1 times my 2x minus 3. And this is all over 1 so that we see that where we can cancel. I'll grab my different colored pen so I can do my canceling. So this factor here will cancel with this factor here. This factor here will cancel with this factor here. And so what I'm going to end up with is simply a negative in the denominator and a positive in the numerator, which is a negative, and then 1 times x is x, and in the denominator I just have a 1, so my answer is a negative x. Beginning algebra or intermediate algebra. Alright, and so that wraps up the multiplication examples. Now I'm going to go ahead and do another video that'll do your division examples, and that way you can look at them separately just in case you haven't done those division examples. And let me pull those up. These two examples right here were the ones that you should have been doing on your own in division, so you should come back for another video on those.